So yeah, I'm going to talk about patent analytics. So some trends that I have been observing. I was in the field of patent analytics. I did my PhD in the field of patent analytics. I was working on patent value indicators, which are there in the patent data. I worked in Germany in a patent analytics company, patent site, which is now acquired by LexisNexis. I built my own patent analytics platform, IP analytics platform, which had trademarks, designs, copyrights, and patents. So we extensively used the cloud platforms. We had a very massive data warehouse. We used Elasticsearch at that time. It was breathtakingly fast. We used to be able to run queries on 100 million patents in less than a second. So yeah, we had lots of experience. So that platform, IPgram, it was acquired by a company in the UK in 21-22. So we worked. So that's about that time only. At the end of 22, AI came. Since then, I have not been in the field of AI, but I have been, trying to keep up with AI. But things have massively changed since 2021. When we built that application. So I'll try to share two or three important points, and also for you as an audience, what you should focus on, what your students should focus on. I'll also try to mention that. All right. So we'll go like why patent data is so important today, uh, and what are the opportunities and trends that are being seen. Then we'll discuss about why data science, the core data science field, is super important. It is way more important than just dashboards and analytics. I'll introduce you to vector databases. So vector databases, OP. I hope some of you are YouTubers who know what OP is. So vector databases, I think that they will become very, very mainstream. And we'll talk a little bit about the sources of data and the security aspects. So yeah, why patent data? Actually, this actually comes from the economic theory. Way back, in the 1960s, there was the economist Jacob Schmuckler, who first used patent counts to, show them, quite to be related with innovation and economic growth. So his book was called Invention and Economic Growth. It was launched in 1966, and the key, the key thing that he talked about in the book is innovators pursue patents in expectation of future profits. Okay, so patents are a tool for doing business. Patents are a tool. Patent filing is done because the innovator is expecting to make future profits out of it. Okay, and that is why innovation is closely related to economic growth. Okay, so whenever you are inventing or patenting, an innovation is happening, it is actually related to future economic growth. It has been countless times seen also in countries. If like the Chinas, you can say, patenting activity has been increasing exponentially in the last 20 years. So that is why, you have also seen that their economy has grown a lot. Same is happening right now with India. India is one of the fastest, in terms of the year on year filings. We are one of the fastest growing patenting countries. So if you are going to have innovation, that is a means to grow your economy, grow the GDP of the country. I hope everything is fine with the voice and everything. Yeah, you can see the slides and everything. uh, all right, so patents are a combination of, so yeah, why patent data? So that's one thing, that patents are a business tool. uh, when a when an applicant or an inventor files a patent, they mean to do business with it. Okay, it's an indication that they mean to do business. Patents are a combination of technology, legal, and business data. It's a very unique source of data because it not only has the technology aspect in it, it is written in a legal way, and it is related to, strategically related to business. Okay, so you basically are having a document which is a combination of three types of data. Okay, and that is why it is worth a lot in the field of economics. All right, so a little bit more on why patent data is so important. So patent data is always available early in the business cycle. So if you see, this picture on the screen, it's the most famous technology S curve. It's called the S curve. So if you would study technology management, you would see that almost all technologies that come, they follow an S kind of a pattern in terms of their adoption and in terms of the patent filing. Okay, so initially there's a brisk rise in patent filing. You can see in the initial phase there's a exponential growth in patent filing, but at that point it's not necessarily that a lot of business is being done. Okay, only when the patent filings start to decline, that's when the maximum commercialization actions are happening for a technology. That is why patents always come before the actual commercialization happens. That is why it is an early indication. So it's a very good piece of data, because since you know it early, it's like a crystal ball into the future. You can predict which industries will grow, which companies will make money, which countries will grow. So that is the tool that you have, because patents come early in the business life cycle. Innovation is not easy to measure quantitatively. If I were to ask you, how do you think, is company A more innovative or company B more innovative? You can say all the different things, but it's always going to be argued, right? Who is more in innovative? But patents, it's one of the most easy to measure and quantitative data that you can use to measure innovation, okay, which in principle is very difficult to measure. Okay, and patent data is again very interesting, because it's like an asset. Patents are an asset. Okay, IP is an asset, and a lot of companies fight for those assets. Okay, any asset is not like unlimited. You can only file that many patents in a field before uh, the marginal new patent is not that much valuable. So that is why it gives you a glimpse of the competitive landscape. That means all the companies who are fighting for a certain technology, you can see it in a very nice chart, for example. Okay, so that is why patent data gives you an idea of a landscape of the industry. Okay, who are the top players, which are the top countries, which are the most rising technologies. So these kind of competitive landscape of technologies you can get from patent data. All right. So what is the role of a patent analyst? So in principle, this is the role of a patent analyst, to identify high value patents. Okay, there are more than 3.5 million patents that are being filed globally. Okay, so all patents are not that valuable. In fact, there has been some research that 5% of the patent population, they are having 50% of the value of the whole bunch of patents. Like you see in this picture, some inventions are not, they never see a patent application. uh, all patents that are filed are not granted. Okay, some are abandoned in between, and all the patents that are granted are not necessarily high value for the owner. Okay, so the goal of a patent analyst is to look for the wheat, is look for the wheat in the chaff. Okay, to see and identify most important patents. Okay, that is where you need good searching skills. That is why you need good business skills, and some data skills to understand which metrics is going to help you to identify the most important or the most valuable patents. So let's move on. Let's see some of the trends and opportunities. In fact, I've been experimenting a bit on patents. So the title of this slide is actually an AI prompt. So I gave Claude AI, can you plot patent data of top 10 patent offices in the last 20 years? Okay, so Claude didn't just give me a chart, it gave me an entire dashboard. I think I sound like AI when I speak this. But yeah, I'm going to show you the dashboard. So you can see this is the prompt that I gave. It could not find direct access to patent data, but it was able to find online. So it's like a really nice agent that if they don't get direct access to data, it found a WIPO report of 2024, and based on that report, it created an entire dashboard for me. So you can see this is how easy building a dashboard is. It took not more than 2 minutes, and it didn't just give me a chart. Like I said, it gave me a lot of insights. So global leader is China. 1.68 million applications were filed in 2023. Okay, quite incredible. Okay, that's almost half of the patent filing. Okay, yeah, here it says 47% of global. India is the fastest growing, 17.2% growth in 2023. The whole world, if you see the global combined data, 3.55 million patents are being filed every year. So imagine that is the job of a patent analyst, right? To find valuable patents from within this, because that's a lot of patents, 3.5 million every year. Asia is having 70% of global patents. So you can imagine where the future growth or the future economic rise is going to happen. This is the data I checked. This is quite correct based on my earlier analysis. You can see the top countries are China, US, Japan, South Korea, European Patent Office, Germany, India, Canada, UK, and France. So these are the, like you can say, the top 10 patent offices where maximum filings are happening. Okay, so here also they can see the market share. You can see also in this chart a unique thing that before 2000, Japan was the highest. You know, the yellow line over here. So quite interesting. And also we've seen that since 2000, Japan's economy has not been doing that well, because you can also see that the number of patent filings has declined compared to what they were doing in the 1980s and the 1990s. So yeah, market share and then some key insights. China's dominance. Okay, they surpassed the US in 2011, and now they are filing almost 3x more patents. Okay, Asia is 70% of worldwide grants. Okay, so 56% it was 10 years ago. India is rising double-digit growth. Technology focus, computer technology and AI, they are the fastest growing category. Samsung is the leading patent filer in the world, followed by Huawei and Qualcomm. So you can imagine which industries are growing also by seeing which companies are filing the most patents. And let me zoom it a bit so you can see. Probably you were not able to see earlier. And regional shift, traditional leaders Japan and Europe have seen their shares decline while Asia rises. Right. So this is what AI is able to do in 2 minutes. Okay. So earlier, you needed some people who could use some Power BI or Data Studio kind of tools. Of course, I gave it some very clean data. I had data from earlier, from one of my from IPgram actually, which was quite clean data. So that is what my point is, that building the dashboard itself is no longer a great core competency, uh, but the background data, the core data science part, is uh, is going to be is becoming more important. Right. So let's get back to the slides. Uh, okay, I see a question. Let me see. Purnima Chandran, if I can answer it. I don't know if I can. Like I said, I have not been in this field for several years. Can you suggest some good IP valuation courses that speak about practical aspects as well as not only theoretical aspects? Uh, IP valuation courses, I suggest you go to L2 Pro India. That is definitely one place you can see. They have IPR commercialization. Uh, I think they have one IP valuation. Let me just check. Standards, funding and venture capital, IP acquisition. Okay, not specifically valuation, but I would suggest you go to EPO Academy. Okay, EPO Academy. You will definitely find some valuation courses over there. So practical aspects also, I think you will find, because other than data aspects, there are cost based method, there's market based method. Okay, and there was a third kind of method. cost based, market based, and some other kind of valuation methods. So yeah, EPO Academy, I would say you should check out. L2 Pro platform, you should check out, and also you should go to WIPO if there are any courses. But I think EPO Academy would be good for you. Can you suggest any good open source AI based search databases that work for life sciences and biotech patents? Mm, I I I don't think I have a very good answer. I can suggest you try Google Patents and lens.org. So LENS lens.org. I know that Google Patents has some search for chemical molecules, so you can search there. Otherwise, check lens.org, or just search online. If you can find some open source. So, all right, let's continue the talk. The second thing I want to show you about dashboards, is going one step above. This is the fuel cells data. Sorry, this is the fuel cells data from IPgram. So I have data from IPgram. This data is a bit old, since IPgram already we were working 5 years ago. So this is the prompt I gave to Claude Code, and I also recorded a video that how quickly you can create a web-based dashboard. Okay, so I have added a file fuelcells.csv in this folder. It contains global patent application data related to fuel cell technology. Okay, use Node.js Express to analyze the data thoroughly. Create a web dashboard with key charts, tables, and insights. Now, the whole process, it took me about 6 minutes or so. And I've actually fast forwarded it. I've increased the speed like 3x. And this is just, my computer terminal, my Mac terminal, where I've installed Claude Code. And you can see I gave exactly this prompt. I had to give some follow-on prompts because one or two things were not correct. So I just asked them to correct it. But you can see it is now creating. It's now creating all the files. Okay, let me make it full screen. So you can see it is now creating the files. It is writing the code for creating a web-based dashboard for putting the charts. And in one go, it did a very good job because the data was correct. I cross-checked all the charts and everything. The data was correct, and it also understood some things went wrong. It already corrected it itself. I had to give it one or two further prompts that okay, initially the cards were not working, so yeah, I again gave it a prompt that hey, there's a certain specific chart that I wanted which it did not give in the dashboard, so I asked it to add that specific chart. So this is just fast forward. This is just fast forwarded. 6 to 7 minutes it took, and I have like made it 2x speed. So this video is like 2 to 3 minutes. And I'll show you the output that it generated. I'll just show you the output. Yeah, sometimes I had to enter give it some permissions to run the code, and you'll see. And yeah, finally I had to give like one or two more prompts, but these were simple prompts that okay, this is not working or that is not working, and I'll show you what it finally created. Let me share this tab. So this is the tab that I'm showing you. This is what it created. Okay, so this CSV file had 500,000 records. So 500,000 records is not that little. It's a good amount of records. There were 120,000 patent applications, and it was related to fuel cells. Okay, so you can see it shows the country and publications. These are all correct. I have cross-checked it. Initially, it did not give top 10 applicants in this kind of a chart, so I asked it to add that, I asked it also to give the top technology fields. You can see which field of technology these fuel cell patents were in. There was some patent strength values there, and here it gives the top applicants and also the countries where they are filing a lot of patents. And these are the unique patents. You can see how many. So Toyota had almost like 10% market share of all the patents in the fuel cell technology. So really interesting, right? So again, this was 6 to 7 minutes job, and AI could spin up a dashboard. So again, my point, with this two examples, is that dashboards itself, just doing stuff on Power BI or creating charts, it's been it will be automated. Okay, it will no longer be the biggest core competency. And I feel that if you are a young researcher or if you are a faculty teaching your students, core data science is coming to the fore. Okay, so this is the skills that you are going to have. Since this is an IPR career summit, I wanted to showcase this part to you, that start learning concepts like natural language processing, okay, machine learning. Okay, you can start with the basics, just like what is tokenization, what is TF-IDF algorithm, what is cosine similarity, what is limitation, stop word, these kind of words of NLP. And you should learn some basic Python. Okay, even that is not needed nowadays, because AI can write Python code flawlessly. But you can test all these concepts of machine learning on your own. Okay, or concept of natural language processing on your own. Okay, so this is going to help you to build a grounding, the key grounding that is needed to have skills that are future proof, so to say. Because again, we have been seeing in this talk, in the keynote talk by Ravi Bhola, and also Dhruva, who shared his knowledge just before me. So he was mentioning that a lot of entry level work is being done by AI, and creating dashboard is like that. So that is why you need core data science skills. Okay, learn about transformers, learn about open source models. Open source models are out there. Some of the models are not even that big. You can just download it on your own computer, use some basic Python code to create the embeddings. I'm going to give you one or two examples so that you can see and get inspired. Learn vector databases. They are becoming mainstream. So one of the things that I will discuss in this presentation is about vector databases and how they are enabling semantic search in patent search kind of AI applications. uh, s- so yeah, so this is what I would like you as young researchers and faculty to understand, is that core data science is what you should be learning. It is AI has made even learning data science and Python so easy, and even there are so many data sets that you can practice. I can also show you some data sets that you can practice. All right. So patent search will be more and more semantic. Okay, by semantic, what does it mean? Semantic means that you don't necessarily write the keyword, but it understands the meaning behind those keywords, okay, behind the phrases. Okay, so that is why I say more and more semantic. I'm not saying that patent search will only become semantic. I'm saying more and more semantic. There's a reason for that. I'll show it to you in the next few slides, why the current way in which patent search is happening with keywords, boolean operators, it's still going to stay. But you can see that patent search used to be dominated by this keyword search, queries, wildcards, Boolean operators. I have a course on patent search, which is a great foundational course. If you want, you can check the link in the description at the end, turnipinno.com. You can see the list of courses. There's a patent search course where I take an advanced course on patent search. So, and classification course. That is what typically was being used. Uh, but now natural language processing helps us to encode the text within the patents. Uh, into embeddings, so-called vector embeddings. We'll see, in action. I'll show you what vector embeddings are. So basically what it does is that something like wireless communication device, okay, in the vector space, it will be similar to cordless transmitter. Okay, now these are different keywords. So if once you do keyword queries, you will not, if you search for wireless communication device, you will not be able to search for cordless transmitter. But in the vector space, okay, these two keywords, these two embeddings are going to be very similar to each other, and hence both of them are going to be returned by the search query. Okay, and again, the beauty of vector embeddings is that you can also do it for different languages. Okay, the vector embeddings in other languages, and you can just search in plain text, and the vector embeddings would see that they are very similar to each other, and both of all the data will be retrieved even if they are in different languages. Okay, and what's even more beautiful is that even images can be stored as vector embeddings. Okay, that means you can have a multimodal search in the future where you can search not just by text, but also by uploading images. Maybe you upload patent images and then you retrieve the results. Right, so this is where patent search, you can say, is going more and more towards the semantic aspect, and more towards the generating vector embeddings. So just a bit of concept I'll share with you before I go on to the next slide. So in patent analytics field, okay, or in patent research field, patent search is the most important factor, right? Because if your in underlying patent data is not correct, the analysis that you will make from that data will also not be correct, right? So one of the biggest skill of a patent analyst is actually patent search. And in patent search, there are two types of errors. Actually, both errors are very different from each other. If you try to reduce one error, you actually increase the other error, and if you try to reduce the other error, you try to you actually, the first kind of error goes up. So this is very difficult, but you need to balance it. Okay, so to get your data set, you need to balance it. So type 1 errors, these are called false positives. Okay, they are basically, you are incorrectly identifying relevant prior art as relevant. Okay, so that means your search query, you are giving a search query, and then you are getting maybe say 5,000 results, and out of those 5,000, 500 are not relevant. Okay, that means you have got 5,000 patents, but only say 4,000 or 4,500 are the correct, are relevant to your technology. So that means it has low precision. That is false positives. Okay, you are identifying incorrectly some prior art, and they are appearing in your search results. So once you build your analytics based on that 5,000 patents, and 500 patents will not be the correct ones, obviously there'll be errors in your analysis. Okay, and then there's a type 2 error, which is called false negative. Basically, it is failing to identify relevant prior art. Okay, that is low recall. Okay, in natural language processing, it's called precision and recall. So precision basically means how accurate is your search, how accurate is your search results. Okay, and recall is how well are you getting your search responses. Okay, how you know how much you are covering and how much you are not losing out. Suppose your search query returned 5,000 results, but there were some 2,000 more patents in the whole database which were relevant to your search in reality, then you have actually missed out 2,000 patents. Okay, that is where you can say the recall is low. Okay, so that is why precision and recall, these are the guiding posts, you can say, of any kind of search, not just patent search, but any kind of search. And these are the most important metrics, you can say, in natural language processing or in search applications. So now what is the impact of this? Okay, what is the impact of this on the current way, the keyword way, which is the method that is being used? you have high precision. Actually, it's a very good thing. That is why I say that semantic search will increase, but it's not going to remove keyword search, completely. Because if you use the right keywords, which a good patent analyst will do, okay, if you have knowledge about the certain industry, you also know the synonyms. Okay, you will know that wireless communication device and cordless transmitter are the same, or a battery or an energy storage device are the same. So that is why with the correct keywords you can have a high precision, but always you will suffer with low recall. Okay, even if you have good keywords, you might miss out patents where the patent has been drafted in a way that it doesn't have those keywords. Okay, but it's still related to the same technology. Okay, so that's why you might suffer with low recall. You might miss out thousands of patents which were supposed to be written in your search query. Okay, so but the fact that if your precision is high, you have narrow queries and there is legal certainty, so all the patents that you have retrieved, they are correct. Okay, that is the idea behind keyword search. But enter vector search. Okay, now it has precision is moderate because it will also get you a lot more patents. That is why the recall is high. Okay, because it is able to understand synonyms, it is able to understand relationships between text and the real meaning behind the keywords. Okay, not just the keywords themselves, but the real meaning behind the keywords. That is why it is good for prior art search, exploratory landscape, or multilingual search. It can also search in images, it can also search in say patents in other languages. So as soon as you have widened your search in other areas, obviously the recall will be higher. You will get more relevant patents in your search results. But as soon as you get more relevant patents in your search results, uh, your precision will take a hit. Okay, it will stop being high anymore, but it may be moderate. So that is why nowadays or in the future it might be the hybrid way. Okay, so the vector search is going to become more and more mainstream because nobody wants to type so many boolean operators, wildcards, and all the field operators. But instead, hybrid might be the way to go, where both precision and recall are balanced. So for example, in this case it would be like you do a vector search you do a semantic search by just entering a phrase, but then you say that this keyword must exist. Okay, like if you say that there's some polymer batteries, okay, and the lithium word must be there. Okay, then it's kind of both semantic search as well as keyword search. So yeah, now I'll show you the say how it impacts patent analytics reports. So essentially, there are four types of patent analytics reports. Okay, if you are working in this field, you will kind of work on four kind of reports approximately. Okay, I'm trying to categorize them so you understand it. The one is the top, you can see, is the regional innovation report. Okay, this is basically a very broad level of doing technology research in certain regions, like in Asia or in certain countries. So here, patent search is not the most important skill because you will likely be working with a big data set, and that means there will be high recall. You need high recall to get all the patents that might be relevant. You will obviously compromise a little bit on precision, but you will need a big data set to work on that. So that is why macro level report, that is why you need a big data set and hence higher recall. After regional innovation report, there might be industry report. For example, if I did do a report on say tractors, okay, in the field of heavy earth moving equipment, not tractors, let's say heavy earth moving equipment like excavators, tractors, all kinds of these heavy earth moving equipment. So that is an industry report. Okay, here the patent search will need to be tuned a little bit more. Okay, it cannot be very wide. It is still, but it's still not that narrow. Okay, it's still, you're doing search at the industry level. Then comes technology specific, that I search only patents related to blockchain. Okay, that is very very precise search. Okay, and then finally is a very accurate prior art search or a freedom to operate search. These kind of searches, when a patent analyst does, you need high precision. Okay, that is where you might need keywords, you might need exact CPC classes to get the results. All right, I hope this bit is clear. So now multimodal search is possible now with vector databases. So just I want to show you like what a vector database might look like. A vector database is having vector embeddings, okay, but vector embeddings are just a list of numbers. They don't mean anything. uh, but I'll just show you how it works. So vector is just a list of numbers. It can represent words that list the numbers. They can represent words, sentences. It can represent the whole patent document, the images, the CPC classes. So anything that is there in the patent, they are turned into vectors or so-called embeddings. Okay, vector DBs are built for semantic similarity search, and this is how what an example might look like. Okay, so if there's a word battery, it has it is depicted by certain vectors. Okay, these are the say the numerical values of the how the word battery is represented in a vector database. Okay, and then there's another phrase, energy storage device. Okay, this is how you can say how it is represented in a vector database. So you will see that both are quite close to each other. In the real, if they are very close in vector space, that is why when the the program is going to search for battery related patents, it is also going to retrieve energy storage device patents, because battery is often written as energy storage device in patent documents. Okay, and you can see the numbers, the numerical values are quite close to each other, so it will perform some kind of a similarity search, approximate nearest neighbor algorithm, or some kind of cosine similarity. And you will see that both these uh, both these word and the phrases are going to be returned. So this is what I mean by a vector database. A vector database is a system built to store billions of such vectors. Okay, you can run it on the entire 100 million patent document, which is if you have raw data of all the patents, and then it's actually quite efficient to search numbers. Okay, searching numbers in a database is much easier than searching complex text. Okay, so once you represent all the patents, all the keywords, phrases, images in these kind of vectors, it's actually easier to find which patents are the closest, or which vector space are very very close to each other. So quickly finding nearest neighbor. So now I actually experimented with it just a couple of days ago. I experimented with it. So I will show you how it looks like, how you could possibly think of doing it. So this is my Google Cloud platform. Okay, and this is BigQuery. So I created a BigQuery data set, and I experimented by creating vectors out of a design registration. Okay, so it's one of our project. If it succeeds, we will launch an AI image search for doing design prior art search, which we are working on. But you can see that. Let me. So this is the name of the model. We are using Google's say Vertex AI. So it is the name of the model. So multimodal embedding, something like that, and it has 512 dimensions. So these are the embedding dimensions. So that means one image is going to be represented by 512 this kind of numerical values, which is a lot. Okay, and and it's associated with an image. I'm not able to show you the image, but it is related. It's this whole all these vectors, they are related to an image. Okay, that image is of a kneecap which is filed for a design registration. And when I asked Google Vertex AI, can you describe these numbers in plain text to me, so it gave me very good answers, like it's cylindrical. So a kneecap is cylindrical. It understood that it's cylindrical. It had like lines the way it was depicted. So all these different attributes of that design is being captured by this vector database. So I think that it is relatively easy way for companies to start building their own vector databases, and have in-house, you can say on-prem patent analytics tools. All right. So I hope I have been able to give you not just some kind of also visually uh, some appreciation of how it might work in the future. So sources of patent data. So obviously there are free databases. Still, I think they are going to be there. So eSpaceNet, Google Patents, Lens.org, which I just mentioned. These are great for idea validation. So if you are in the early stage of inventing, uh, you can look up patents. You can look up the legal status. They have very good coverage. 100 plus countries is no joke, and but they lack analytics. They lack many other features. Uh, uh, they have basically they have been built on raw data, so they don't have that many data quality improvements that commercial databases have been able to do. So I think that these are really good tools, but if you are a very like a serious IP professional, these tools can be a bit frustrating because they don't have that much incentive to give you new features or add new things. So that's where commercial databases come in. Derwent, Clarivate, LexisNexis, Patseer, PatSnap. The subscription cost can be very significant, but then if you build an on-prem solution, that can also cost you a lot. Significant data quality improvement. So they have been improving their data quality for decades. That is the important part. So they have harmonized the applicant names. They have improved claim text. Some vendors like Derwent, they have written abstracts in simple English language rather than very difficult, pedantic kind of patent language. And yeah, they have many features. You can save your data sets, you can collaborate with others. So it's like a lot of features, and possibly there are some vendors who claim they have more than 120 countries, so they have actually been able to get data from individual countries separately, which probably the free tools don't have. And many of them have semantic search inbuilt. Patseer had semantic search even before the advent of AI, so to say. But nowadays, I think it is quite a leader in AI related prior art searches with very good quality data. So all these things mean a lot. These are probably worth spending, because if you end up building your own tools, it takes time, it takes money, and also you may not be able to do it with exactly that level of quality which they have been able to do, say, for last 20 years or so. Okay, but this is basically my point of this talk, that I think that raw patent databases, they are going to make a comeback. They are going to be adopted by many companies, also because of security issues, because I think data ownership is becoming a topic of discussion. We don't know what is happening, how the model is using our data, and it is invention and sensitive data. So the companies are a bit wary of sharing just about anything with any public AI models or these popular AI models. So some examples are, these are usually in raw files. So you will see JSON, SQL, or even PDF files. Individual patent offices have it in PDF format. You require programming skills and really, really good data management skills. So you need really good developers. Uh, but you have complete flexibility. Okay, that is the important part of this. You have flexibility. You can build. There are no limitations. Uh, but of course, if you decide to uh, you know upload it on the cloud platforms, the costs might escalate at that scale. But maybe if you have, you invest in your own servers, you can maybe reduce your cost long term. The coverage varies, so you might have to accumulate data from different sources and build a comprehensive data sets. But the good thing is that you have full control over this data. You have flexibility. You can enhance this data using public open source models. So you can search. There are many public open source models. One of the most popular I've seen is this Patents BERT A. So basically, you can say it's a deep NLP based hybrid model for patent distance and classification. So I think it's based on the sentence transformers. So all the things are written here, how you can use this model. It's open source. You need basic Python to turn your sentences of your patent document into vector embeddings. Then you store the vectors in your own database, and then make use of it. So yeah, you can search Google, Kaggle, Hugging Face for patent related models, and just experiment with a small data set and see, at least build a culture, uh, before you build a full fledged application. So I think many companies, they are building their own LLMs, their own transformer based models, because the foundation model may not be fine tuned for patents, because in a patent, one sentence can be even 200 words. Like a claim is like a very very long sentence, and sometimes the foundation models with popular AI services, they are not able to cater to that. So many companies are fine tuning their own models to cater to patent data per se. All right, so yeah, this is what I think, that raw patent databases are going to make a comeback. I think many companies have already started to do it, to train their own models, test their own models, and probably security is the most important reason. So on-prem deployment, private vector databases, creating up vector databases is quite straightforward, and then you can maintain it on your own. You have full flexibility and control. Um, so there are many other benefits. Okay, of course you need to have well defined guardrails, who is going to access it, what you can search on popular LLM providers, what you cannot search in these popular LLM providers. And one more way, I think, is that it could be that teams are going to have smaller data sets available to themselves, because if you are working in a technology field, it's unlikely there are more than 200,000 relevant patents in that field. So it's a good idea to create these smaller data sets, and the teams can have only access to those data sets, because what's the point of always querying 100 million patent documents or 120 million patent documents, if you're working, your whole field is only 200,000 patents. So yeah, this is my talk. So this is what I thought are the biggest trends: vector databases, your own fine-tuned transformer-based models for patents, and semantic search making a entry big time. And for building a career for students and faculty, you must think about core data science skills. You must start learning it on your own. Start small. Start learning natural language processing, simple concepts, machine learning, and then use some of the open source models with small data sets. And that's how I feel like the future careers in patent analytics might have a lot of this.